Hello.
Good afternoon.
Sir. Good afternoon, sir.
Can you see my board screen?
Yes, sir.
Okay, so what we are talking about yesterday is the induction principle and general case, right? Your initial value of n might be some n, and then assume that the statement is true for all k. Assume statement true for some k greater equal capital N, and then try to prove for k plus 1. So it is exactly same as the previous one, but the only thing is base case could be some larger number, right? Not necessarily 1. And same logic, same induction works in this case also. Right. So let us see. Do you understand this general case? No doubt in this case. Arbitrary base case. I think you understood this. We discussed this last time. There should not be any difficulty. So what are the steps? Assume for some n and prove for some n, some larger n, which is base case, and then assume for k greater equal n and prove for k plus 1. That's it. So let us try to work out some examples so that you can understand it easily. Okay, so so example which we are going to discuss is prove that n factorial is greater than 2 raised to n for all positive integers.
Excuse me, sir.
Yes.
Yesterday's homework, the first one, 3 raised to n is greater than n square for all n belongs to natural number. So can you explain us that sum again? Step 3, only the step 3.
Okay, so what you said, 3 raised to n greater than n square. Okay, so 3 raised to n, okay, 3 raised to n greater than n square for all n. This was problem, right? This was the yesterday's problem,
Yes,
homework,
sir.
which I gave.
Yes, sir.
Yes, sir.
Right. So for n is equal to 1, the answer is clear. It is true because n is equal to 1, then we'll have 3 on left side and 1 on right side. So clearly it is greater. Then assume for n is equal to k. So assume for n is equal to k. Right. So assume for n is equal to k. That is what we are going to assume here, induction. This is second step. This is first step.
So
So
3 raised to k is greater than k square.
very good. 3 raised to k is greater than k square. This is assumption. Now we are going to prove induction. So third step. So they start with 3 raised to k plus 1, and we want to check whether what is our ultimate last step. This should be greater than k plus 1 square. This will be our last step, but I don't know right now I don't know whether it is true. So but I ultimately I want to get this right. 3 raised to k plus 1 is greater than k plus 1 square. This is our final step which we expect. 3 raised to k into 3, right. Now 3 raised to k plus 1 is uh, uh, 3 raised to k plus 1 I can split in this way. 3 raised to k into what 3. Is it clear? Okay, now I will replace 3 raised to k by k square, and I will write 3 as it is. Then which quantity is bigger? If I compare this quantity and this quantity, which quantity is bigger?
Left one.
So left quantity is bigger because 3 raised to k is bigger than k square, k square, and 3 as it is, no doubt, right? But then I want to say that check whether it is greater than k plus 1 square. Fine. So how to get this? But this is actually 3 times k square, right? Then that means it is k square plus k square plus k square, correct? So 3 times k square means k square plus k square plus k square. But if I write here k square as it is, and I replace k square by 2k, and I replace k square by 1, and I add this. Now compare these two quantities, this quantity and this quantity. So which quantity is bigger? I am replacing k square by 2k, right? So let me check first of all, k square and 2k. Which quantity is bigger?
K square.
Huh,
Levi
but
same.
but there is a problem if k is equal to 1. If this is 1 and this is 2, right? So in that case this is not true. Then if I k is equal to 2, then no problem. This left side is 4 and the right hand side is 4. So I can say it is greater equal. Correct? Am I right? If k is equal to 2, no problem. So, but we are not worried about k is equal to 1 case, right? But we are worried about the larger, higher case. So, in particular, here add case n is equal to 2. So, if n is equal to 2, what is the problem? 3 raised to 2 and 2 square. This is 4 and this is 9. This is true. So, for n is equal to 2, again it is true. So, we are not worried about n is equal to 2. So, we are not worried about k is equal to 1 and k is equal to 2. So, we are worried about larger. But for larger things, k square, so k square is greater than 2k for k greater than 2. Right, this is true. Am I right? Do you agree? If k is greater
Yes,
than,
sir.
if 2 is k is
Yes,
greater
sir.
than 2, then k square is greater than 2k. That is certainly true. And for k is equal to 1 and 2, not issue, because we already verified for n is equal to 1 and 2. That is true. So forget about 1 and 2. Just think about larger case, right? So therefore, sometimes we need to, initial base case need to be verified for 1 and 2 also, for or for some previous steps that we need to do. Okay.
So,
Yes.
so, but how can we replace 3 raised to k by k square? Means it's not equal, no?
No, no, not equal.
The 3 raised to k is greater than k square means 3 raised to k को आपने रिप्लेस किया ना k square से वो कैसे मतलब
So what is induction hypothesis? This we are assuming. Second step. What I am assuming supposed to be true. 3 raised to k is greater than k square. This I am assuming ki I am saying that ki this is true. And therefore I am replacing 3 raised to k by k square. So which quantity is bigger? This quantity.
yeah
Right? So 5 is greater
okay
than 3, and if I multiply it by 2 on both sides, then what happens? The still this quantity is bigger,
yeah okay sir
right?
understand yeah
Okay. Now, therefore, 3 raised to k plus 1, which is 3 raised to k times 3, which is greater than k square by 2, and this is by step 2, induction hypothesis. Not, uh,
सर सर पण सर
yes,
जेव्हा आपण 3 रेस टू के प्लस 1 ला 3 रेस टू के इंटू 1 असं लिहितो,
uh,
सॉरी 3 रेस टू के इंटू 3 असं लिहितो,
uh,
तर ते सेमच झालं. म्हणजे आपण 3 मल्टिप्लाय आणि डिवाइड नाही करत आहे ना,
no,
आपण
no, no.
फक्त त्याला त्या एक्सप्रेशनला वेगळ्याच प्रकारे लिहितोय.
That is what this is equal to. I am not saying ki something else. This is equal. This is same as this. When I am saying equal,
मग
then the values are
हा
same.
हो, पण मग इनइक्वालिटीच्या त्या साईडला आरएचएस ला के स्क्वेअरला 3 ने का मल्टिप्लाय केलं, म्हणजे कसं केलं?
3 raised to k is bigger than k square, and
येस.
these three as it is.
हो, पण
See, a is greater than b and some c is positive number, then ac is greater than bc. This is true for any numbers.
या
Remember, this is something general. That is what
या
I am using here.
पण मग सर ते 3 रेस टू के प्लस 1 इंटू 3 राहील ना.
ते काही का असे ना. What is 3 raised to k into 3? 3 raised to k plus 1 is 3 raised to k into 3. This is true,
ओके ओके ओके, कळलं कळलं, काय केलं कळलं. ओके.
right?
हा हा.
And now I am replacing 3 raised to k by some smaller amount,
येस,
and I am keeping
गॉट इट.
3 as it is, so the result is smaller,
येस, गॉट इट.
right? And but this is certainly 3 times k square. But 3 times k square means k square plus k square plus k square 3 times.
येस, गॉट इट,
Now,
गॉट इट.
now I am replacing k square by 2k, but 2k is smaller than k square for k greater equal k greater than 2, right? So this is certainly greater than, and k square is anyway greater than 1 because k is a natural number and square of natural numbers are, or all natural numbers are greater equal 1, so their squares are. So certainly I can say that this is greater than or equal to k square as it is, no doubt. And what property of real numbers I am using? If a is greater than b, c is greater than d, then a plus c is greater than b plus d. This is what a basic property of real numbers, which we'll discuss in detail later on while studying real numbers. But from schools itself, you are dealing you are dealing with such type of properties, right? And therefore there is no problem now ki how I am replacing. I am not arbitrarily or I am not forcing to get the equation. I am using all the rules and law regulations, or I am not violating any rule of mathematics, right? So you should understand this. My purpose is not anyhow I want to get this. This is not my purpose. My purpose is using all the rules and mathematical logic how to get this. That is what the aim is. Okay, so this step is clear. K square is as it is, but k square is bigger than 2k, so I replace k square by 2k, and I replace k square by 1, so 1 is smaller, so the result is smaller, right? And see, this is a philosophy. Suppose you have 3 bags. This bag has 5 kg mangoes, second bag has 5 kg mangoes, third bag has 5 kg mangoes. Then what I will do? I will keep first bag as it is. From second bag, I will remove some 2 kg mangoes. Whatever I remaining is the smaller amount, right? From third bag also, I will remove 3 kg mangoes. Whatever remaining is smaller amount, and then what is adding together is a smaller amount than what was previous. Is it clear? So, but what is this? What is this? what is the rightmost expression? What is the rightmost expression? What is the rightmost expression? K plus 1 bracket square. Is it true? Is it true?
Yes, sir.
Okay, and therefore now again recall the entire expression. Recall the entire expression. I started with 3 raised to k plus 1, but I could express 3 raised to k plus 1 as 3 raised to k into 3. But by induction hypothesis, 3 raised to k is bigger than k square. So if I replace 3 raised to k by k square, the resulting amount is smaller, which is same as k square plus k square plus k square. Again I can replace k square by smaller amount, which is 2k, k square by smaller amount, which is 1. The result is smaller, which is k plus 1 square. So ultimately what I get? Thus, what I get? 3 raised to k plus 1 is greater than k plus 1 square, right? And therefore from k to k plus 1 we are able to prove. Is it true? Is it clear now?
Yes, sir.
Yes, sir.
Okay, fine. And hence by induction it is true for all natural numbers, right? Then now we can declare it is true for all natural numbers. Okay, let us come to our example which we are talking about. Yes.
Sir, please explain cos t plus I sin t example also.
No, that you should do something, right? You should not expect everything from me, otherwise will not learn anything, right? You should think about it. I will okay, I will give you hint. What was the problem? Cos t plus I sin t raised to n. This is our we expecting that this is cos nt plus I sin of nt, right? For every natural number, this we were expecting. Okay, let me erase this. This we are expecting. What is n is equal to 1 case is true. It is clear because cos t plus I sin t if n is equal to 1, and what is the right hand side? Cos t plus I sin t, same. So it is clear. Or assume for k that ki cos t plus I sin t raised to k is cos kt plus I sin t, right? Then start with cos t plus I sin t raised to k plus 1. Start with this, and then you can split it as cos t plus I sin t raised to k into cos t plus I sin t. Is it true now? Whatever I have written in the last expression, is it true?
Yes, sir.
Yes, sir. Now use induction hypothesis because we are assuming that the k step is supposed to be true. Then I can replace this bracket by what? What is second step?
Cos kt plus I
Cos kt plus I
sin
sin
kt.
Very good. So this is same as cos kt plus I sin kt, and the second bracket whatever is this, and multiply these two brackets and use properties of the angles addition of sin and cos. That will give you answer, right? Unless you do some calculation you cannot understand the difficulties, and you cannot get immunity to solve such problems, right? So if you want to develop your immunity you should come across some difficulties. Otherwise if you feel that there should not be difficulty and everything should be nice, then this will not improve your immunity, and you will not be the stronger to fight or tackle the difficult problems, right? Is it clear?
Yes, sir.
Very good. So okay, so uh, what was our problem? We are talking about this problem. N factorial is greater than 2 raised to n for all n greater equal 4. This is a problem, right? Now, and now what is the problem for n greater equal 4? This is true, and therefore what is the base case? So in this case, what should be base case?
N equals 4.
N is equal to 4.
Right, n is equal to 4. So prove for base case n naught is equal to 4. But if n naught is equal to 4, then what is left hand side? 4 factorial. N naught or n is equal to 4. So 4 factorial is 25. And what is 2 raised to 4 is 16.
16.
And certainly it is greater. Right? And therefore the result is true for n is equal to 4. That is base case. What should be the second step? Induction hypothesis. Induction hypothesis. Assume that the statement. Please keep your mic off. Immediately you should keep your mic off. Otherwise it creates lots of disturbance. So, okay, so assume that the statement is true. N is equal to k. That is, and what is k now? K is greater equal 4. We are not saying now k greater equal 1. We are very sure that k must be greater equal 4. So, and that is 2 raised to what is our statement? N 2k factorial is greater than not n factorial. K factorial is greater than 2 raised to k. This is our statement. Okay, so now step 3. Step 3 to prove for n is equal to k plus 1. This is what we expect now. So that is what we expect. Right, we expect now. We want to prove. We are assuming for k and we are expecting what? K plus 1 factorial is greater than 2 raised to k plus 1. This is what we expect. Okay, now let us start with, let us start with k plus 1 factorial. This is what we want. But this is what? K plus 1 times k factorial. Am I right? K plus 1 factorial is k plus 1 times k factorial.
Yes.
Fine. But by induction hypothesis, what is the second step? K factorial is greater than 2 raised to k. So I will keep k plus 1 as it is, and I will replace this second amount or second quantity by 2 raised to k. Right, so now compare this k factorial and 2 raised to k. K plus 1 first factor is same, no doubt. But 2 raised to k is smaller, right? 2 raised to k is smaller. And certainly this amount is bigger. Am I right?
Yes, sir.
Okay, fine.
Yes, sir.
So ultimately what we have 2 raised to k is in times k plus 1 is uh, smaller than k plus 1 factorial. Okay, but we want to get that the answer should be k plus 1 factorial greater than 2 raised to k plus 1. So how to get this? Okay, note that k plus 1 and 2. What is my k now? K is, note that for k greater than or equal to 4, what can you say about k plus 1 and 2? Which amount is bigger? My k is greater equal 4, right?
K plus 1.
Right, so this amount is bigger. Once your k is greater equal 4, for example, k, what is the least possibility for k? 4. Then 4 plus 1 is 5, it is greater than 2. If it is 5, 6, 7 in all possible values of k, this amount is greater than 2, right? Therefore, k plus 1 factorial, which is already greater than 2 raised to k times k plus 1, and now I will keep k 2 raised to k as it is, and I will replace k plus 1 by some smaller amount, which is 2. Then which quantity is bigger? Which quantity is bigger?
2 raised to k into k plus 1 is bigger.
Very good, because k plus 1 is bigger than 2, because our k is anyway our k is greater equal 4. But then what is this?
Sir,
2 raised to k.
k, pl-
Yes.
k plus 1 is greater than 2, na? Not equal to 2.
But so it is greater than, but there is no harm in saying that greater equal. When we say greater equal, that means there are two possibilities, either greater or equal. If one of them is true, then this statement is true. Okay, for example, let me clear this doubt also. I can say that 3 is and 2, which is greater 3. But there is no harm in saying that 3 is greater equal to. Because when I say 3 is greater equal to, that means one of the case must be hold. That is either 3 is greater than 2 or 3 is equal to 2. But one of them is true, so certainly this expression makes sense. Right? This expression makes sense, right? Do you understand this?
Yes, sir.
And therefore, what is 2 raised to k times 2? It is 2 raised to k plus 1. This is what we were expecting. We started with k plus 1 factorial, and ultimately we reached to 2 raised to k, and this amount is bigger. Is it clear now? Any doubt in this? Thus, k plus 1 factorial is greater than 2 raised to k plus 1. Hence, the result is true for n is equal to k plus 1. Right. So result is true for n is equal to k plus 1. Is it okay now? Hence, thus, by induction hypothesis, by induction, because all the steps of induction works here, and by induction we can declare that n factorial is greater than 2 raised to n for all natural numbers greater or equal 4. Certainly it is true. Now we can believe that this is true for all natural numbers which are greater or equal 4. Right, and for 1, 2, 3 this is not true, so this expression or this result is not for 1, 2, 3. It is after 4. Fine. So now this in this induction the steps are similar to the what previously we discussed. Only thing is base case could be the larger number. Now we'll see the most general version or strong induction. So strong induction.
सर एकच सेकंड थांबा, एकच सेकंड.
Yes. Yes.
नाही ऍक्च्युली आधीचा सम कम्प्लीट करत होतो म्हणून. एकच सेकंड.
Okay. So
डन डन डन.
so second principle. Second induction principle. So second induction principle, which is in some general, or you can say general, more general. General principle. So what general principle says ki let A is subset of natural numbers. Suppose 1 is in A. Suppose 1 is in A and second condition is 1, 2, 3 up to k in A implies k plus 1 is in A, then A is nothing but set of natural numbers. Okay, let me explain this in detail. So what strong principle says, suppose you choose any subset of natural numbers, whatever it may be, but if that set satisfies following properties 1 and 2, then that set is nothing but set of natural numbers, the complete set of natural numbers. What properties? Suppose it contains initial element 1, and if it contains one initial elements to some k elements, then it contains next element. Suppose it contains first 10 natural numbers, and from that if we can see that it contains next also for any choice of k, then that set is nothing but set of natural numbers, right? So in this, what logically what it says, if it contains first number, and if you choose any 1 to up to 100, and from that if you are able to see that it contains the 101, if you choose 200 elements 1 to 200, and if from that if you are able to see that it contains 201, if it happens to be true for all k, or you choose any number of elements consecutive from 1 to that number, and from that if you are able to check that it contains next, then it contains all natural numbers, right? What does it mean? If your set satisfies these two properties 1 and 2, then it contains all natural numbers. That is what the meaning of this induction principle. In weak induction, what was the case? If it contains 1 and if contains k, and from that if you are able to prove that it contains next, then it contains all natural numbers. That was the weak induction. And in strong induction, if it contains 1 and it contains from 1 to k, then from that if you are able to check that it contains next, then it contains all natural numbers. Okay, so if when we apply this strong induction, what are the main steps? Steps are similar. So important steps to apply strong induction. So what are the important steps? Step 1. What is step 1? What should be the step 1? If you see this induction principle, what should be the first step? This step is same as the previous induction, right? 1 belongs to
Yes,
A.
sir.
That means what should be the first step? Prove for
Proof for
n
n
is
is
equal.
equal to 1.
Very good. What should be the next step? What is the next step? Assume for k,
Yes.
right? Assume for 1 to k, and from that prove for k plus 1.
Yes.
And then conclusion, it is true for all n. That is what the logically induction means. So therefore second step is assume that this is induction hypothesis. So I am writing in short because we are now you can understand it. What is induction hypothesis? Assume that the result or statement is true for n is equal to 1 to up to k. Now we are assuming for all 1, 2, 3 up to k. In weak induction we were assuming for k only, right? That is, statement Pn is true for n is equal to 1 to k. This we are assuming in second step, induction hypothesis. Then step 3, proof for n is equal to k plus 1. Right. From induction hypothesis using step 2. So using step 2, proof the third step, that is proof for n is equal to. So first and third step is somehow same, only second step is different, right? So, but this gives more power, right? Because we are assuming for all numbers from 1 to k, and this gives some additional power in our hand, and that makes our job easy to prove some statements. Right. So is it clear? Steps are clear now?
Yes.
Okay, now let us try to solve some problems so that you can understand. So assume that x1 is equal to 1, x2 is equal to 2, x3 is equal to 3. Okay, so assume x1 is 1, x2 is 2, x3 is equal to 3 for n natural number n and greater equal 4. So we have defined something x1, x2, x3 for 1, 2, 3, and now we want to define for larger values of n. So for n greater equal 4, define xn is equal to xn minus 1 plus xn minus 2 plus xn minus 3. Right, so show that the aim is the target is show that x raised to n is less than 2 raised to n for each natural number. Okay, first of all, try to understand the statement of problem. Then we'll go to the proof. Okay, do you understand the problem? We have defined basically what is the situation here. We know numbers x1, x2, x3, x4 and so on. We know numbers. We have defined some numbers. How many numbers we have defined? How many numbers we have?
K
Okay.
numbers.
Infinitely many, right? x1,
Yes.
x2. x1 is 1, x2 is 2, x3 is 3, and x4 is now xn minus 1 plus xn minus 2 plus. So what is x4 from this? So x4 is this is the definition of xn. So what is x4? x4 minus 1, that is x3, plus
Plus X2
x4 minus 2, that is x2, plus
plus X1.
x1. But x1, x2, x3 are known, and therefore what is this? 3 plus 2 plus 1,
6.
it is 6. Right, now what is x5? x4 plus x3 plus x2, but x4,
X2.
x3, x2 are known now. Therefore, it is 6 plus 3 plus 2, and therefore it is 11. Right? So, can you define x6? Can you get value of x7? Can you get value of
Yes.
x100? Can you get value of x200? Right? So,
Yes.
you need to do some calculations, but certainly you can find value of x200. Right, and therefore the expression which we have defined, it gives values of all xn's, right? This gives values of all xn's. Now what is our claim? Ki every xn is less than 2 raised to n. For example, what is x1? What is x1? X1 is 1,
One.
right? So x1 is 1 and it is less than 2, which is 2 raised to 1. What is x2? 2, which is 2
Less
raised
than 4.
2 raised to 2, right? What is x3? 3, it is less than 2 raised to 3, and this is true for all. For 1, 2, 3, 4, 5, it is easy, or you can, if you do some, spend some time, if you sit down and do calculation, you can prove for x100 also. But can you prove x1000? Okay, by you spend 2 days and you to check for x1000. But can you check for 1, 2001? So that is difficult, right? And therefore we should prove in general ki xn is less than 2 raised to n for all each n. So induction helps ki you can prove for general. So what is first step? So step 1. So what is step 1? Prove
N is
for
equal to 1.
so for n is equal to prove for n is equal to 1. So yeah, if n is equal to 1, then what is xn? Xn is x1, but x1 is 1, and clearly it is less than 2 raised to 1, which is 2, right? So 2 raised to n, and therefore xn is less than 2 raised to n because n is 1 in this case. So therefore true for n is equal to 1. Fine. So what is second step? Induction hypothesis. So assume that the statement is true for is true for n is equal to 1, 2, 3, k, right? Am I right? So I should assume that our statement is true from 1 to k, right? So that is, what does it mean? x1 is less than 2 raised to 1, x2 is less than 2 raised to 2, x3 is less than 2 raised to 3, and so on. Xk is less than 2 raised to k. This is my assumption now, right? Because I am assuming that statement is true from 1 to k. Now what is my third step? So step 3. What is my step 3? We prove for n is equal to k plus 1. That is to prove. We want to prove for n is equal to k plus 1 means what we need to prove? X k plus 1 is less than 2 raised to k plus 1, right? So this is what we expect. Am I right?
Yes, sir.
Okay, very good. So then how to do this? So to prove this, let us start with xk plus 1 and try to get that it is less than 2 raised to k plus 1. So we should start with, so consider what we should consider xk plus 1, right? So begin with xk plus 1 and try to get, so consider xk plus 1. But by definition, what is xk plus 1? How do we define xn? We define xn
x1, x1,
X,
x2 till
xk
X,
plus
xk.
xk minus 1 plus xk minus 2.
right. So reduce by 1. So this is xk
X3,
plus xk minus
XK
1
plus 1 plus
plus,
XK minus
right, xk minus 2. Very good. Okay. But by induction hypothesis, we have what we have, xk is less than this. We are assuming the xk is less than 2 raised to k. Am I right?
Yes, sir.
What about xk minus 1? Can I say that it is less than 2 raised to k minus 1?
Yes, sir.
Yes, sir.
Yes, sir.
Certainly, because I am assuming ki x1, x2, x3, xk, then what is the previous? Xk minus 1, what is the previous? Xk minus 2 and so on. That means before xk everything satisfies this, right? Therefore, certainly I can write this. Xk minus 1 is less than 2 raised to k minus 1. Can I say that same thing is true for xk minus 2? Right? By induction hypothesis. Okay, so very good. So now think about xk plus 1. So therefore, xk plus 1, which is xk plus xk minus 1 plus xk minus 2. Now I will replace xk by 2 raised to k. I will replace xk minus 1 by 2 raised to k minus 1, and I will replace xk minus 2 by 2 raised to k minus 2. Right, and therefore this quantity is larger because uh, this quantity is bigger than this. Second term is bigger than second term here, and third term here is bigger than third term here, and therefore if I add bigger amounts, then certainly the total sum will be bigger because left hand side is a smaller amount. Fine. Okay, now 2 raised to k and 2 raised to k minus 1 and 2 raised to k minus 2. So if I take 2 raised to k minus 2 common, what will remain in the bracket? Right, 2 raised to k is what? What is 2 raised to k? K minus 2 plus 2. Right, so if I take 2 raised to k common, what is 2 raised to k minus 1 is? K minus 1 is k minus 2 plus 1, right? So what I should get if I take 2 raised to k minus 2 outside this bracket and common from these three terms?
2 raised to k plus 1.
So
No,
what I
no.
should get? What I should get? 2 square plus 2 plus 1. Am I right?
Yes, sir. Yes.
Yes, sir.
Very good. So this is what 2 raised to k minus 2, and this bracket is 4 plus 3, that is 7. 4 plus 3 is 7, right? And now uh, if I replace 7, so 2 raised to k minus 2 as it is, and if I replace 7 by 8, what I will get? Which quantity is larger? This is our previous quantity. This is the quantity which I obtained if I replace by 7 by 8, the larger number, right? 2 raised to k minus 2 is as it is. So certainly this quantity is bigger. Am I right?
Yes, sir.
Okay. So, but then this is same as 2 raised to k minus 2, but 8 is now 2 raised to 3. 8 is 2 raised to 3. What is it? 2 raised to k minus 2 plus 3, because bases are same 2, 2. I can add indices. So I can add their indices, right? So what is the power? K plus 1,
K plus 1.
right? And so ultimately what we obtain thus. Now you look at the entire expression. I started with xk plus 1, and I just found that it is less than 2 raised to k, 2 raised to k minus 1 plus 2 raised to k minus 1. Further, that amount is less than 2 raised to k minus 1 into 8, which is 2 raised to k plus 1, right? So ultimately where I reach? 2 raised to k plus 1, and in between I got the sign which is strictly less, and therefore ultimately xk plus 1 is less than 2 raised to k plus 1, right? Thus the result is true for n is equal to k plus 1. And how we could prove this? Using induction hypothesis, right? Hence xk is less than 2 raised xn is less than 2 raised to n for all natural numbers. Okay, so is it clear now?
तिसरी स्टेप रिवाइज करता का सर?
Which कुठली step?
तिसरी स्टेप सर.
Okay, so start with xk plus 1, right?
हा या सर तिथूनच. नाही
xk
वरून
plus
सर कन्सिडर बसून सर.
consider xk plus 1 is consider xk plus 1, but xk plus 1 is by definition xk plus 1 is xk plus xk minus 1 plus xk minus 2, right? But by induction hypothesis xk is less than 2 raised to k, xk minus 1 is less than 2 raised to k minus 1, xk minus 2 is less than 2 raised to k minus 2, because that is what we are assuming in second step. This is our assumption, right? For all xk's before x particular k, all these numbers satisfy this inequality, right? Okay, now therefore xk is less than xk 2 raised to k, xk minus 1 is less than 2 raised to k minus 1, xk minus 2 is less than 2 raised to k minus 1. So if we compare first term and first term here, so here the first term in second expression is larger. Again, second term in second expression is larger. Third term in third expression is larger, and therefore this total sum is larger because I am replacing each term by larger amount. Do you understand this? Right? समझले का? Second step, this step is clear?
Yes.
Yes sir.
Okay. Now take 2 raised to k minus 1 common. Right? Take common means what? Suppose I have 2 raised to 5 plus 2 raised to 4 plus 2 raised to 3. And if I take 2 raised to 3 common, what will be in the bracket? 2 raised to 2 plus 2 plus 1. That will be in the bracket. If I take 2 raised to 3 outside, then what will be here? Second power of 2, here first power of 2 is 0th power of 2. So that is what when we take 2 raised to k minus common, what remains inside? 2 raised to 2 plus 2 raised to 1 plus 2 raised to 0. Right? But this bracket is 7 and I am replacing 7 by some larger number 8. Right? I can replace. No, this is not wrong thing, right? Certainly 8 is greater than 7, so I am replacing 7 by 8, and therefore the product becomes larger, correct? But this is nothing but 2 raised to k minus 2 into 2 raised to 3, because 8 is 2 raised to 3, right? And then the bases are same, 2, 2. I can add their exponents, so k minus 2 plus 8, which is 2 raised to k plus 1. Fine.
Sir, how do we replace inequality sign?
Here.
Here xk plus 1 is equal to xk plus xk minus 1 plus xk minus 2. Then it is lesser than sign, but we take common 2 raised to k minus 2. Then we directly get equal sign.
But because this quantity is 7, this bracket is 7. Is it clear? ही जी स्टेप आहे, ही स्टेप आणि ही स्टेप एकच आहे, फक्त मी तिथं ऍड केले ते ब्रॅकेट मधले नंबर्स. हे दोन्हीचं व्हॅल्यू एकच आहे, सेम व्हॅल्यू, राईट?
ओके.
हा जो नंबर आहे 2 raised to 2 plus 2 plus 1, ह्याची व्हॅल्यू काय आहे? 7. तीच मी इथे लिहिली, फक्त वेगळ्या फॉर्म मध्ये लिहिली, नाही तर व्हॅल्यू सेमच आहे, राईट? लक्षात येत आहे का? इज इट क्लिअर?
Yes, sir.
Sir.
हो. So, see, this is a philosophical fact, and you need to understand all this philosophy, because what is a philosophical fact? Suppose you have 100 rupees in your bag. This is your bag, right? But inside bag, there are small wallets or packets. This packet contains 50 rupees. This another packet contains 30 rupees, and another packet contains 20 rupees. Right? So you have 100 rupees in your bag, but inside bag there are small packets. One packet contains 100 rupees, another packet contains 30 rupees, and third packet contains 20 rupees. Suppose you remove the money from packets and put in the bag together. What will be the amount? 100 rupees. Same thing I am doing here. You have packets. This packet has size 4. This packet has size 2. This packet has size 1. But the total size of the packets is 7. And therefore, the amount is not going to change. Right. So, don't get confused about such type of things. So, think over it again and again. You will be sure about it. Right. Okay, fine. Now, let us think about some different problem. So, for n natural number, define an as I am going to define numbers an. A1 is equal to 1, A2 is equal to 8, and an is equal to an minus 1 plus 2 times an minus 2 for n greater equal 3. Right, then prove that. Prove that for each n, an is equal to, prove that an is equal to 3 times 2 raised to n minus 1 plus 2 times minus 1 raised to n for all natural numbers. Now, problem is clear. How do we define numbers an? A1, A2, A3, A4, A5, and we have defined infinitely many numbers. A1 is 1, A2 is 8, and what is A3 now? Right, in this, what will be A3? The definition for all n greater than or equal to 3 is this. So, from this, can you find value of A3? A3 is
Sir, 10.
10.
A2 plus 2 times A1. Right, so but A2 is 8 and A1 is 1, so it is 10, correct. Similarly, you can find value of A4, you can find value of A5 and so on. So you know the values of all ANs now. The claim is prove that all these ANs can be expressed in this form. The AN is equal to 3 times 2 raised to n minus 1 plus 2 times minus 1 raised to n. So you think about this problem because you know the induction hypothesis, and we'll discuss more problems during our practical sessions. So we'll not spend our time solving problems, right? Because in theory our main aim is to discuss more about theory, and in practical sessions we'll discuss more about the practicals, right? Problems, right? And how to apply concepts in solving problems, because you have to cover lots of theory part, and once you understand theory, once you understand theoretical part, you can understand the you can solve problems easily. Now I think it is 2 o'clock, so we should stop here because you have to join the another class, right? So any doubts, any difficulties?